beyond what you have done thus far. Andy, do you have a problem number for this one? Where's the improper one in homework? Oh, 6. And then other guys who got farther in homework, are there more improper ones or just the one? Just that one? Okay. So this is basically just to help you on number 6, but this is a big idea just for you guys to keep in your back pocket. It's from pre-cal. Like literally there were kids in here yesterday and I was like, hey, pre-cal kids who are doing partial fractions, like right this second as we speak, what do you do if you have an improper fraction and you always divide? So that also comes into calculus as well because we're trying to rewrite, and the way to rewrite improper rational functions, is to divide. So quick practicing, and to be honest, I actually want this to be a little bit more similar to homework if you don't mind, so I'm going to make this a cube. Remind me real fast, how do we do divide? Those of you guys that did number 6, see if you can ace this one, because a lot of you asked me questions on it. So see if you can ace this one after doing your number 6. And for those of you that haven't done number 6, you'll be ready for it. What goes in the box? The numerator goes in the box. Come on, guys, it's pre-cal. Now or ever was a time to show off. Let's show off here. Top goes in the box. What goes on the outside? And we're trying to ask ourselves, how many times does x go into 2x cubed? Hold on. How many times will x go into 2x cubed? Yeah, 2x squared times. Because then we distribute 2x squared times x is 2x cubed. And then we distribute again with a minus, and we have 4x squared. However, once we write that down, think division. Do we add or subtract as we go down? Subtract, because it's division, right? So think away those arrows just to make it a little bit less messy. But I have 2x cubed minus 4x squared. Now pause. Why did I add a 0x squared? Exactly, because I'm missing a term, and I need this to all be like terms as I combine. So I'm going to end up with those going away. That was the point 0 minus a negative 4x squared. It'll be a positive 4x squared. And guys, I just bring everything down because who knows what you're going to be needing. It's a polynomial. It's not quite like numbers. Just bring it all down. Now I'm pausing, and I would love for anybody who's like, huh, to ask a question now. Pre-cal, long division. I'm trying to rewrite it. I'm trying to break it down to make my job simpler. Improper. We always divide first. Any questions? Then you guys finish the division. I'm going to walk around the room. I'm not going to do it. You finish it. Finish the division. This will be helpful for number 6 on homework. Or if you already did number 6, to make sure you understand the idea fully. As you guys keep going. Did you finish it?
I think so.
Okay, cool. So what came next? X goes into 4x squared how many times?
Sorry, Sandy?
Yeah.
Did you say, 4x?
Mm-hmm. Let me go ahead and do that multiplication really fast. But what happened when you subtracted? Could you keep going, Victor? And go for it.
Plus 15.
And what happened when you subtracted?
27.
Victor got me to the end of the division. Somebody else tell me what to do with my remainder. Oh, say it one more time, Hez. What? Yes. And the question is, what do I put it over? So coming back up here at the top, yes. So I get to keep that denominator because it's parts per whole. So I'm going to do my 27 over x minus, whoops, not a 3, that's a 2. I thought I had enough room, but I don't think I do because there are 3 terms. But this whole goal was for us to be able to rewrite. Make this so much simpler. Only works when I have improper that I can divide. And I can say that my original integral is the same thing as the integral of 2x squared plus 4x plus 15 plus. This is helpful in many places in homework. Not the division part, but what I'm about to show. Question. Where do I need the u substitution? Only the fraction. So what does the sum and difference rule for integration let me do? Do I have to do u sub right now for everything? No. I can literally go ahead and split this up and say, oh, you know what? With that sum and difference rule, I can take the integral of this guy dx and then the integral of that guy. I can separate them. Because that beginning part, easy cheesy, it's power rule. Let's go. That ending part, we'll get there in a second. So I end up with 2x cubed over 3 plus 4x squared over 2, which reduces, plus 15x plus the integral of 27. Wait a minute. Can't I pull the 27 out? And make it just the integral of 1 over x minus 2 dx? How are we doing? Piece by piece? So question, what is this in section 4.6? Because we had this forever card, and this forever card that got a little bit hidden, a little bit overshadowed by the warm-up problem last time. I believe it's forever card number 38? 39? 38? Something. I should switch the card. I know up here it's 39, but remember, we condensed product and quotient rules, so our numbering is 1 off. But we can go ahead and use, I put 1 over u up there. We can think of 1 over x. It also works with the u. I'm going to do my u sub. But those of you guys that have gotten really used to u sub, question, is this an easy one or a hard one? What's u prime? Just 1. So therefore, this is the exact same thing as just the integral of 1 over u du, which is gorgeous, because then all I have to do to finish my answer is what, guys? ln. Even though that 27 could totally pop up and be a power. It doesn't take away the absolute value, and who wants a 27th power anywhere in their answer, and I say no. How are we doing, Colkins? Go ahead, what's the question? I didn't write it. I said it and I didn't write it. Lucas, thank you. Oh my goodness. Good morning, so far. Nobody else caught it? Or you were all just laughing at me? Because the 15, I didn't do anything to it. I just wrote 15 again. I never actually took the integrand. So I had 2x cubed over 3, 4x squared over 2, 15x, and I never wrote the x. So Lucas caught it, and I had to go ahead and put it down. Yeah.
Your outlet. Where did you with the 1 over the x?
Yeah, so I took this, and since there was a 27 in front, I could have thought of this whole thing as 27 times 1 over u, which ends up to be 27 ln of the absolute value of u. Sorry. It's a mental one. Andy.
May I use the back?
I suppose you may, sir.
Thank you.
He's been here early. He's been working on that. Man, just look at that water bottle. Jug, keg, thing. Okay. Guys, there's another half to this. I do have some like, ooh, let's get so tricky. But we're not going to get so tricky because I got so tricky last time. We do need to talk about e to the u's and b to the u's, but I believe that's like the second part of homework. Does anybody have any questions then on problems that you think need LM? I'm going to move this real fast, the challenge ones to after homework. Maybe that'll be a warm-up like next time when we're not quite so like that warm-up last time was brutal. But do we have any WebAssign questions? It could be even filling in the blanks. I know some of you guys were like, say what? Give me a question if you guys think you have a WebAssign question. Oh, should have it ready or else. Sarah, what's up? Okay, I'll go peek at it. Anything else, Hovan? Did you have one? 11, 12, 14. Let me go peek at them real fast. So I have 11, 12, 14. Oh yeah, those are all solid ones as far as what we're doing. So let me go ahead and freeze the screen for just a second. Let me go get some clean. Because you guys are in a copy of stuff. That's funny. Is that like the first time you've seen that? Really? Oh, weird. Okay, here we go. Starting on number 8. Hovan, what should they not do? Yeah, don't multiply. After my warm-up the other day, you might be like, we have to do Pascal's triangle. Please don't. Please don't. Instead, go with your gut. I'm hoping. Maybe your gut's not there yet, but hopefully it is. If you were to right now choose a U, what would you choose? Yes. What's DU? It's nothing. It's absolutely nothing. But wait. Okay, so we have some extra stuff. But question, what do we do if we have extra stuff?
Integrate on crack.
Yeah, no, he likes that way. He likes that way. We go be extra with our substitution. How do we be extra with our substitution? We solve for x. But no, it is integration on crack. It's substitution on crack. You got to keep going. It's crazy. You're not done yet. You should not be. The integration might be. Okay, so solve for the x, u plus 1. And what do I do with that u plus 1? I plug in some more. So I'm not done with that other stuff. Actually, I don't want to go red yet. I don't know why I did. Sorry, that's awkward. Okay, so u cubed du for the dx. And then any place there's an x, I'm going to go plug in a u plus 1 and a u plus 1 minus 2. What have I just done? I said, hey, I need some extra stuff. So it's like, okay. Figure out what that x is by solving for it in the u equals x minus 1. So plus 1 on both sides, x equals u plus 1. Plug it in. Now, I should simplify some stuff for sure. But now the problem just blew wide open because that guy's going to be u minus 1. Cool. This is something that I could FOIL. Cool. Now, it's not an improper fraction, so I'm not dividing, but what can I do since it's a proper fraction? That denominator is nice and neat.
Bring it up.
I can bring it up. Now, Sarah, this is kind of what you were saying earlier this morning as far as we could bring it up by thinking about it like a -3 power. I think a lot of you guys have been doing that process because it's easier to you, and that's okay. You can bring that up as a -3 power for the purpose of rewriting. I would end up with a u to the -1 power. Let me go sideways if you guys don't mind. I could have a u to the -1 power minus a u to the -3 power. That's not bad, except I really hope that you change one of these to look like a fraction. Anybody know which one? Nope. The power rule does not work for a -1 because a -1 is the same thing as u over, no, 1 over, and 1 over u goes back to who? Yeah, connections. Anybody like seeing connections? Okay, well that's alright. Talking to the wrong class. Sorry, those are the BC kids. I love connections. That's why I love Marvel, because there's connections everywhere. T-Swift songs, because there's connections everywhere. U prime, wrong one. We already did that. That was way up here. Let's see, but we're not quite there yet. But does anybody see there's another way we could have gotten there? What would have happened if I had just done u squared over u cubed? Isn't that 1 over u? And then 1 over u cubed is really just u to the negative 3. I don't know. My brain still likes heart method better, but you guys love this negative exponent thing, so that's okay. Just be careful. Negative 1 does not work with power rule. That's a 1 over. That's an ln. So, equals ln of absolute value of u. Remind me, how do I do a power rule? Add 1, which would be u to the negative 2, divide by a negative 2 would be plus, and then a little like boop-a-doop. You guys don't need me to finish this, because what's the last step you need to do? Plug it in.
U sub.
Plug it in. Yeah, do the backwards u sub, right? Bring him back. Bring him. Oh, it's not that. Oh my goodness, why are we complaining? Okay, number 11.
Wait, what if the 2 at the bottom of the u squared would be negative?
Yeah, but it was a minus. And so the minus and the negative just cancel out to be a positive. No, but you're right though. It was a negative, but with the minus. I love that someone, what was I saying? Asked about number 11 because number 11 says tangent. Why? Why do I need a whole new special, gross memorized rule for tangent? I thought tangent was nice. I thought tangent had a derivative of. It does. What does tangent have a derivative of?
1 over cosine, right?
What does tangent have a derivative of?
Wait, oh, it's ln.
Pretend you're around the room because we should have done that today, but people relate. Oh, do not start using that or I will definitely start doing parties. But derivative of tangent gets you what?
Sec squared x.
Secant squared of x.
Oh.
Wait a minute. That's the derivative. I would need a secant squared in my integral to go backwards. Oh, but there's bound to be somebody with a tangent that I can go backwards from. Nope, not that one. Nope, not that one. Nope, not that one. Nope, not that one. And nope, not, what did I just do? This is the derivative of who? Sine. This is the derivative of who? Cosine. That's the derivative of tangent. That's the derivative of secant. That's the derivative of cotangent. And that's the derivative of, those are my 6 trig functions. That's all I've got. Where does tangent come into play as an answer? It doesn't. Unless. Unless what? Where does the ln come in? With secant last time, it was super hard to see, so I said just memorize. With tangent, actually, it's not hard to see at all. Because, cool kids, if you just rewrote him using the quotient property, what would you think your u is? Because it would be the bottom. What would your du be? Times?
2 theta.
You're fine. Now was the time to do it, but what's the derivative of 2 theta?
2.
2. How many of you are doing the trick of dividing? And just, Sarah, this is the thing you're asking today. I can just get that d theta alone, right? And plug it in and see what happens. So if I were to divide everything, this is kind of like what you guys were doing at the boards the other day, right? With that tricky one. When I make my substitution, what do I got? The integral of sine 2 theta times. You're throwing in your u because that's where you got them from. You're throwing in what d theta equals, which is du over negative 2 sine 2 theta. Question, what happens to those sine 2 thetas? Where does that negative 1/2 go? What am I left with? Why is there an ln?
ln.
Final answer would be negative 1/2 ln of who?
Just the absolute
ln absolute.
ln of u? And what's going to happen when you check with a derivative? What's going to happen when you derive an ln? The derivative of ln of u is 1 over u times u prime, which will be a sine over a cosine, which gets me back to my tangent. Now, I rewrote the tangent. But what does the forever card say you can always do with the tangent of u? You can always go back to negative ln of cosine. Now, I showed you a tangent. Homework showed you a tangent. You could rewrite this with a sine over a cosine, and you could do your good old u sub. You could rewrite this as a cosine over a sine. You could do this with a good old-fashioned u sub. It could work. You're like, okay, I just won't memorize those. But the problem is, rewriting this, not so easy. I don't have a du. Rewriting this, not so easy. I don't have a du. Which is why I showed you guys last time the secant one, and I said, you know what, I'll show you that it works. I'll use the rule, take the derivative, and show you that it works. I'll check it and show you that it works. But please, please, please just memorize. It's in a forever card. You guys should know what that means. Tangent and cotangent, you can get there. Secant and cosecant, it's way too hard. Dun, 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 dun. Oh my goodness. There we go. Oh, so for those of you guys that are like, wait, there was a rule. Why didn't we just use the rule? If you would use the rule, your u would have just been 2 theta. Your du would have just been 2 d theta, which we would have moved the 2 to the other side. We would have rewritten it as 1/2 tangent of u, du, which would take us right here to the bottom, because then the integral of tangent of u du is negative ln of cosine of u, absolute value of u plus c. Go ahead, Josh. Yep, don't get lost. Number 12. Who's your u? Oh, 1. Wait, what? There you go, there you go, there you go. Du. Come on, are you getting better at derivatives as you're taking integrals? Are you getting better at basic integrals as you're facing the harder ones? This is the beauty of calculus. If you allow it to happen, you will get stronger in the basics as you progress. What's du? Derivative of 1. 0. Derivative of sine. Cosine. Cosine of what? T. So then what is my d? T. Got it. Some of you might go straight to a plug-in. That's awesome. That's a shortcut. Go for it. Others of you are like, no, I like that dividing thing. I like that. I'm just going to get this and then plug in thing. Cool. Go for it. It'll be useful for all kinds of problems. It's not cost. It's cosine of t. When we go to plug in, you guys should end up with 1 over u. Well, okay. I'm skipping steps. Cosine of t all over u times du. Oh, why'd you guys find this one hard? Isn't it just a du over u or a 1 over u du? And that should lead us back to a who? ln of u plus c. Plug it in. Why'd you need me for that? Number 14. Number 14 is asking us to take a derivative. Are you seeing this? Oh my goodness, I don't know why so many kids do so bad on the mock exam. And then the actual AP exam. And on any AP practice, when all they need to do is read. What does capital F prime say? I need to take the derivative of who? The integral. Don't get scared. We have a forever for that. And I know right now you might be scared, but just think, if you can get that FTC Part 2 memorized. FTC Part 2 says anytime you need to do, guys, what is ddx? Ooh, Sarah, this was like a weird fill-in. Like you had to put d over dx to remind yourself it was a weird fill-in in one of those Master It tutorials. What does this mean in the theorem? What does that mean? Derivative, exactly. We're just taking a derivative, right? So when I'm trying to find f prime, I am taking the derivative of f, and what I do to one side, I just do to the other. Now I'm trying to remind you guys of what FTC Part 2 says so that we can kind of use it, right? FTC Part 2 says anytime I am taking the derivative. Ooh, question. Is this one of those a to x ones or a to u ones? There were two different variations. Is it a to x or is it a to u?
You could substitute it for like the other variable.
You want to think, is it just an x alone or is it something more complicated? Something more complicated. So we're going to call it or think of it as a u. Does that make sense? X alone is just literally to x. U is anything other than x, which x cubed is other than x. Of f of t dt. Oh my goodness, it even has t's in the FTC Part 2. Do you remember what this tells me to do? The derivative of any definite integral from any constant to u of some function f of t dt is equal to, come on, what's it say? Good thing we didn't do Forever's Around the Room today, but what about Friday? F of u times u prime. We talked about it way back in the day. This is FTC Part 2, which says, how do I do this? Well, I say u is equal to x cubed. I say du is equal to, well, we're not really doing an integral. Instead, we're just doing FTC Part 2. U prime is equal to 3x squared. So if I plug in, I have 1 over a derivative and an integral. They have that inverse relationship, that undoing relationship, but I can't just cross it out because I had bounds that were plugged in. That x cubed got plugged in. I take my function, it stays exactly the same. The derivative undid the antiderivative. And all I need is u prime. Yeah, you know how to simplify that. Andy, your hand was up a second ago. I'm sorry, bud. What's up?
Oh, it was just asking to plug in the x.
Does that make sense? So when we were talking about this in class, we talked about f of the upper bound times the upper bound prime. And that's exactly what I just did. F of the upper bound times the upper bound prime. FTC Part 2. I did not do any integration. I just used the idea. I know what an integral is. Benny, did you want me to look at any of those tutorials? Some people have had me walk them through step by step. Are you sure? Okay. There is some funny things. I know, Andy, you wanted us to peek at number 6 real fast? Yeah. But I was thinking while I'm pulling up the actual WebAssign, it's, oh, I went out of it. Hold on, guys. There's this whole, like, I gotta freeze it. Hey, you've seen me use the... Want me to show the division real fast? Yeah. So with the division... Oh! Shush! If your homework is not all the way done, what should you be doing right now to redeem your time? Pick up where you are as someone else is asking me a different question. Andy just wants to see the division real fast. Sarah, go ahead. Yeah, definitely. Andy, hopefully you've done that 0x cubed, 0x squared. As you could be doing homework. We plug in that x squared. No, that wasn't a burn. It's just a reminder for those that sometimes forget. And then we do x squared. That's an x to the 4th. Boop, boop. Here we go. Put the minus. Ba-doop, ba-doop, ba-doop. Cancels. Don't forget to distribute your negatives. So many mistakes can happen, kid, if you don't distribute that negative. I saw Hovan yesterday. I think, Hovan, do you do this every time? You just flip all the signs? Yeah, and that keeps it, and Noah's like, that keeps me honest, that keeps me safe. That's what I showed in pre-cal.
What's the other option? That's how you have to do it.
Just do the arrows, or just, I mean, you would have to get your parentheses and then think distribute.
Just go and change those.
Yeah, I think that's safer. So then, Andy, we would get negative x squared, then bring down. Now, you might not have realized you can go one more because these degrees match. I can do a -1, and I will have it match again. It's where some other people might make some mistakes, and I distribute, and I distribute. I need to subtract again. Change all your signs. With my color coding, it's a little bit easier. Oh, it's just x, because the 1's go away also. So how is it with the remainder of x and y? Hezzy, you got this right last time. How do I write a remainder? Good, so it'd be x over what? Got it. And what was the purpose of this whole thing? Was saying I can look at this differently, and I can see it as the integral of x squared minus 1. But what's the strategy of me splitting this up into pieces? I can do this guy super basic with power rules, like 1/3 x cubed. Oh. Mo, am I not sharing? I'm so sorry, kid. I thought I was. I'm going to take a picture real fast.
Oh, come to class.
Victor says hi. That was the long story short of that. Hold on. If I take away the screen share right now, she's going to roast you guys over her chat now. Don't you guys have some group chat going on? All the girl talk? No? I wasn't supposed to talk about that one? You talk about it in my class, it's not my fault. Alright! 1/3? You think I'm not listening? I really try not to, but sometimes I just, how can I help it? You're screaming it. 1/3 x cubed minus x plus, what do I have? Why did I split up the integrals? It's easier because this is basic, and what's that mean? Not basic, it needs u sub. Does that make sense? So I can take this guy and I can do like u is equal to x squared plus 1, du is equal to 2x dx, so dx is equal to du over, right? I just need to do u sub on this guy. With the integral of, there's my u, there's my x, here's my du over 2x, and then I can go ahead and be like, woohoo, that goes away, but that's a 1/2 that comes out. What? And then 1/3, just kidding, don't need to know, x cubed minus x plus. Andy, I think you're probably good there, because I just need to go to 1/2 ln absolute value of u and plug in. Although, what? Do you see what they did? Why is there a square root that magically appeared? Like, what happened there? There's my ln. Here's my absolute value. I have a 1/2 in front. I have a 1/2 in front. What do you see, Andy? It's a power, exactly. It's a logarithm. So I can go ahead and say, hey, this guy, he can come up as a power. And a 1/2 power is the same thing as? Boop, 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 boop. Wait, hold on. Where'd the absolute values go? Yeah, the square root would be imaginary if it was a negative. That's one way. Like a negative can't come out of a square root. Only positives can come out. The other way of looking at it is that this is always positive, so actually you could have gotten rid of it. Forgot it doesn't work in this program.
Oh, yeah.
You can get rid of it right there.
Yeah, if it was squared, it's going to be positive.
And it's +1, right? If it was -1, maybe you could have some fractions, but with the +1, it's not really necessary. Okay. WebAssign, just remember, hang in there with the tutorials. Ask me if you guys have any questions. Remember, they're meant to guide you step by step. This will only be on the screen for about 30 more seconds, and then it's gone. So if you want a picture of it, grab it. Actually, hold on. I can do more technology than that. Give me a second.
Wait, why wouldn't it be absolute value?
Andy, what's inside those absolute value bars is x squared plus 1. Oh, nice. And it doesn't copy the gray? Oh, I would have done this more often. X squared is always a positive. Plus 1 is always a positive. By nature, this is always positive. This is redundant.
Okay.
Does that make sense?
Yeah.
And with the redundancy, they just get rid of it. But also, when you throw a square root on top of it, only positives can come out. So it's still, like, always positive, if that makes sense. Lucas, what's up, kid? It's okay, and then WebAssign should mark it right, but remember, we are aiming towards half of our points on the AP being multiple choice. Where you're going to have to match it to the nice answer. Hold on.
Is there a difference between absolute value and just positive? Like is
Absolute value is forcing the always positive issue. Functions, some of them are naturally always positive and some of them are not. So then some of them need that forcing and some of them don't.
So if it's like something like x squared, is absolute value of x squared and x squared
Exact same thing. Yeah. Because remember, an absolute value on the outside flips a graph. Anything that's below, it flips it to be up like that weird W graph. But an x squared is already above, so there's nothing to flip. So for those of you guys that are more graphical in nature. Now, none of you guys asked me questions on any of these, but can we just quickly talk about it? I think I've already shown you guys this idea of b to the u. Some of you like writing it as like an a to the u. It means the exact same thing. In WebAssign, I feel like they might be using the a to the thing because I've heard some of you saying it, so you've been seeing it somewhere. Maybe it was in our earlier integration rules. I just do B for base, like that's my natural inclination from pre-cal. But remember that if you are deriving like a log base B or like a B to the U, remember boolimbu? Like there is this extra ln of B that comes out. Same thing here. Derivative of log of U is like ln of U, but there's an extra ln of B with it. So they're so stinking similar to those more basic guys of, or the ones you remember more, I should say, of e to the u or of ln of u, where it's just 1 over u prime, but that's because ln of the base of ln is e, ln of u is 1 and it goes away. Or like this guy over here, the derivative of e to the u is just e to the u times u prime, but that's because ln of e is just 1. So technically, the more general rule is this guy. We just memorize these ones because they simplify our work if we're like in the midst of a problem. And we can aim for e's and aim for ln's if possible. But what that means then for our integration is if we're integrating an e to the u, yeah, we got that, but do you also know that b to the u is also just b to the u? I just need to account for that extra constant, just like I do with power rule. I divide by m plus 1 because there's a power rule coming. With b to the u, I divide by that extra constant that's coming. I divide by ln of b because when I derive, that little extra coefficient is coming. But once again, can you memorize? Yes. Once again, have I made it a whole forever card to keep you studying it all the way up to the AP? Yes. And it should have shown up somewhere in homework, but it seems like you guys didn't really mind it too much because you found the rule for it, but just kind of giving a quick reminder. So then, if I was to give you, ready, set? We're not going to actually solve these all the way, but can you guys just help me out with the u subs? What would my u be for the first one? And what would my du be? U prime, yeah, negative 1 or just negative dx. And then we would plug in. And when we get to our, hopefully, you guys would get there, e to the u du with a negative on the outside. Hopefully you would get back to your negative e. That's why I have my answer be clear. Negative e to the 3 minus x, and then you guys, hold on, I've integrated. The integral of e to the u is e to the u. My integral is gone. I've had to kind of like not literally slap some of your hands, but like point out on your paper, erase that integral. You've already done it. Just put your bounds over here and say, okay, it's time to plug in f of b minus f of a, etc., etc., etc. But can you make the connection of the u's and then the actual integral? What would be the u for the second one, guys? What would your du be? Negative 1 dx. So when I go to plug in, I have negative. Now, if you want to, you can add an extra step in here, and you can say something like an a or a b is equal to 5. If you want, you could put in that b to the u if you want to ignore the 5 for a second. And then du, but somehow, whether you just get really good at being like, it's a number, it's okay, that's a b, that's an a, you need to be able to get to the point where you are getting back to, hey, I know I have that b to the u or that 5 to the u, but I need to offset by that 1 over ln of 5, because when I take a derivative, b to the u, ln of b, I need it to reduce times u prime. Oh, and then I'm done? Yeah, because that's a plus c. Never mind, I solved that one. I was just too lazy on the other one because it had bounds. What would be my u of the next one? Yeah, are you seeing that you should go in the denominator, go inside the squared, e to the x plus e to the negative x? So then du is equal to e to the x times e to the u, sorry, plus e to the u times u prime would make that a minus. Hopefully you'd also think of doing things like, hey, I can factor out a 2, I can rewrite. Then I'll have my e to the x minus e to the negative x with a little bit of work. Hopefully you guys could get to your integral of u to the negative 2 du, which would just integrate to b, add 1 with a negative, so it'd be a 1 over, and my e to the, let's see.
Wait, why did you?
Oh, because the derivative of e to the u is e to the u times u prime, which is your negative 1. And I was just trying to show minimal work. Sorry, I'm skipping. So cool. And then last but not least, what's your u of this guy? Sin x, yeah. Because it is that b to the u idea. Don't worry, the cosine is going to be taking care of u prime right here. So where I'm going to end up with 2 to the u du, and I love that. You can make it a separate letter if you want, but I just have my b to the u. I can solve that as I get down my integration rules. And all I'll have is 2 to the u offset plus c. You guys are seeing some rules are tricky and we just need to get them memorized, right? And the more you have the rules memorized, the more natural the flow will become as you put in the reps. And that's the end of section 4.6. So that warm-up, I apologize. It was just too brutal, and I need to change that next year because it was just too much. I should have just gone straight to the, hey, 1 over, you guys know this. Let's build on that a little bit. That would have been nicer. You've already seen most of the rules of this section. The ones that are unfamiliar are probably the ones to do with b to the u. Even though you've seen them, this is a section to practice it, and mostly answers that have ln's in it. Answers that have ln's in it. Okay. We need to talk about the calendar real fast. You guys already double checked, and I think this deadline is, we checked everywhere, right? 11:59? As we check there, let me go ahead and get back into, here we go. 11:59 also. I do have your last month 0 period stamp sheet. Theoretically, we should be getting that in today. Emily's already processed some of them, so if you haven't turned in your last semester, no, last 2 months, January, February stamp sheet, just make sure it's face up right over here in the AB folder, and we'll make sure to get that processed. If you need through the end of the week, just talk to me. You guys know me. I'll try to get you points. But in our, a lot of you already asked me about this one, like in Math Lab. Andy just showed me exactly how much work he's been doing, which is a lot on this homework, because he says, I know u is supposed to be x. But it's not so much that u is supposed to be x, as in your experience, u has typically been the denominator. But in this case, if you make u the denominator, it's like, it didn't help, right? Like it doesn't help at all. So what if u is not the denominator? What if this is an integral beyond what you've seen before? And what if there was something else to choose? What would you choose? Exactly. The question is, does this make a big difference? And the answer is absolutely, because let's just say for now, if there are any logarithms.
Oh, is it that L-I-A-T?
Yeah. For now, if there are any natural logs or logs in an integral, make u equal to the ln or the log. And what I showed, like in BC, there's this little acronym called LIATE. And LIATE is for like a more complicated integration technique called integration by parts. But LIATE kind of helps us with tricky, I wouldn't say traditional, but tricky U-sub. If you have a logarithm, there is absolutely no rule that we have memorized that says, oh yeah, the integral of ln is. We don't have that. We have 1 over u becomes ln. We have tangent becomes negative ln of cosine. We don't have anything, any rule for an ln. So we got to get it out. And the only way to get it out is this. But check what happens. It's actually quite gorgeous, because then if I go plugging in for dx and plugging in for my u sub, I'm going to end up getting the integral of, there's an x there, the u comes in here, this guy becomes an x du, and those x's are like bye-bye. That came from the u prime of the ln. So that over x, yeah. No. That was not my main player. That was just like that was a u prime that came in. So then all of a sudden, I'm able to do 1/3 u cubed. Let's see. And I go plug in and chug in my ln. Here's another question I got a lot after school. What do you do if your ln has a power but not inside the ln, not the x, but the whole ln? Just a few of you would be like, oh, I can bring down the 3 and the 3's go away. Dun, 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 dun. False. That's not the property. Sorry. The property says, power property, I need to have that only with the x. If it was with the x, I could bring it down. But when the whole ln is raised to a power, there is nothing you can do to simplify. Log properties are for things inside logarithms. This time the ln is the inside. So Andy is nothing. Okay, we all stretched out just a little bit? Sarah, go ahead. On which one, kid? And that's 4.5, right? The U sub one? Okay, let me put 2. This one was nasty because WebAssign didn't do it the way I would have done it. I'm going to show it for Mariah too because she's on Zoom. They skipped a big step here. I would have done. I would have done some in-between work.
Yeah, I didn't know.
Is just du, but divided by 2. So it's like 3 of this. So if you multiply this by 3, then you get to So then you also have to multiply the bottom three so that it so that's why it's 1, 3 u, so then you multiply the top of 3. And then you get to this. And then that's your du, so you can take that out.
And then Benny, if I was to show work, I would have done it this way. Like somehow you wanted this to match up with that. And so Vaughn, I think, has already mentioned a GCF. Victor was like, I would have moved this whole thing over and then plugged in. So I just kind of showed the work of what if there had been an in-between step. So if you had plugged in that whole expression, that guy would have been gone, and then du over 3u would have led to the 1/3. That's what I would ultimately be integrating. But they wrote it weird. I didn't show it. If anybody else got stuck on number 5, Rocco or Hezi, if you didn't get to number 5, this is one that I've had multiple questions on because they didn't really show their work. So you might want to take a quick little mental note or a quick little picture of what the work would have looked like that led them.
Can I ask you a question about
About what?
Homer or not?
4-6. Let me get to 4-7 just so we can see the beginning of it, okay? And then, if there's time. But I am here today during 7th too, for lunch. Okay. Let me just get us started in 4-7. I know you guys are like in homework troubleshooting mode. And it's not that I need to finish 4-7. I don't. But I do need to start 4-7, okay? I do need to start 4-7. Normally, I would have you guys look up in your forever cards, etc., to go ahead and solve this guy. Let me just take a second and solve it for you as you get your notes open, just to kind of expose you to the need for what we are, where we are going next. Do you remember secant, inverse, sine, inverse, tangent, inverse? It's a thing. Do you remember secant inverse is one of those nasty ones that says... Alright guys, I'm only asking for 15 minutes, okay? We already took a break and it lasted 3 times longer than I meant it to be. But it was productive and that's okay.
Is this 4.7?
Yeah, just the intro. You don't have to write this down, but I do want to show it to you and then I want you to write this down, okay? So hold on. The derivative of secant inverse of u, old-fashioned, was 1 over absolute value of u times the square root of u squared minus 1 times u prime. Why am I bringing him back? We have gone backwards from absolutely every single derivative rule except for product and quotient, because product rule technically is an advanced technique that we're not going to have to worry about. Quotient rule, there's not even that I've seen anybody that comes back from a quotient rule. At least not by hand. But we have not touched the inverse trig rules. The inverse trig rules would say, if I wanted to derive this guy, I would get dy dx is equal to 1 over absolute value of u, which Siobhan, you might notice this is redundant again because of that already being always positive. X squared plus 1 squared u squared minus 1 times u prime. However, this can be rewritten. I know you guys like to stick it to the man. However, that doesn't mean that everybody does. This would be 2x over x squared plus 1 square root of, simplifying this guy with some quick foiling, would lead me to being able to write x to the 4th plus 2x squared. Why am I showing you this? Because we just did a whole section of work where we were taking integrals of things with nasty fractions, and I just wanted to show you real quick, if we had had extra time, if this had been like you coming in this morning, having you review your forever cards, etc. There are other messy fractions out there that go back to what you would not expect, at least not based on what you see. Not all messy fractions go back to ln. Not all messy fractions can be divided away. Not all messy fractions can be rewritten to ignore. Some messy fractions will be headed back to inverse trig as well. And so if I was to, yeah, Ken.
I think the example shouldn't have been like on the bottom. It would still have been the absolute value of x squared plus 1.
I don't need the absolute value. This is redundant because of that whole this guy's always positive and plus 1 is always positive. So it was just redundant. Yeah, but good catch. This is where we would normally have started if there were lots and lots of time. I'm going to actually start things just a little differently so that you guys can get the big idea, aka the rules. So let me steal that real fast. Let's come back to these guys on Friday. But let me get you right here. Okay, I'm going to freeze the screen because you guys can get the title. The title is, what do we do if we have inverse trig? And yet, if we have inverse trig, just like if we have an ln and an integral, we're just going to make it the u. The question isn't if we have an inverse trig inside. The question is, what if we are supposed to be getting inverse trig outside? And all of a sudden, we have a whole nother set of rules. And all of a sudden, we have a whole nother set of rules. We're dealing with messy denominators. LNs might totally be the way for some. We're troubleshooting through a homework where it's like it's not always cut and dry, but okay, make the u the bottom. If there's an ln in an integral, make it the u. If there's inverse trig in an integral, make it the u. But I'm not so worried about what if it's inside the integral. We can get trained over that, but the problem is, what if I have other weird stuff in the denominator and there's no inverse trig in sight? Will you know to go backwards? And that's what we have to work on to finish up chapter 4b. Exactly. They're just derivatives backwards, but the problem is, Andy, think about the homework you're just finishing. Doesn't this look a lot like some of those LNs? And on the AP, they're going to have something like number 3, and in the multiple choice, they're going to have LNs, they're going to have tangent inverse, they're going to have some power rules. The question is, which one is it? Does that kind of make sense?
Yeah.
So we have to know the difference. It's all about learning the difference when you know to go back. I think I might just land on, sorry, I'm totally rearranging, but I'm rearranging for the purpose of giving you guys the short, sweet version that we can then build on without doing the crazy warm-up of last time. Okay, I think I like where this is headed. Cool. So can you guys hang in there with me for 7 more minutes? We okay? Okay. Once you have the rules written down. But then I have on the next slide just some straightforward examples. I'm doing the opposite of last time. Rules, straightforward examples. We'll talk about the ins and outs and all that jazz next time. But hang in there with me. I have one more slide, okay? Hang in there. Once you have the rules, do a quick little like stretch it out. Throw the pencil down for a second, wiggle those fingers. And I'm hearing a lot of that happening, so I think we're pretty close to being able to switch. All right, here we go. Straightforward examples. If we finish these, we're done, okay? If we finish these, we're done. Based on all the work that you've done in section 4.6, the question is, would you have made u 9 plus x squared? Probably, right? Let's be honest. It makes sense. U is equal to 9 plus x squared. Du is equal to what? 2x dx. You would have done this whole PS. I'm saying you would have, you would have, you would have. You might not want to be writing this down right now. I have something else over here. You would have, you would have, you would have. What would have happened if you had plugged this in? You would have gotten 1 over u, yay, times du over 2x, boo. Oh, wait, but no, we were empowered last time. That if we have anything extra, what do? We come up here and we say, why are you saying, oh no, Josh, it's not a big deal, solve for, oh, why'd you say, oh no? It's a square root, because I'd have to do u minus 9, and then the square root of that is equal to x, and then I'd be plugging that in, and I would get 1 over u, square root of u minus 9. Did I make it any better? I made it a, okay, so hold on, if it's an inverse trig, maybe we should have started that to begin with. Check it. Did it look like an inverse trig to begin with? Now that you know or are reminded about what inverse trig look like. Yes. This looks like an arctan? Question mark? So you have to think about who is arctan. Well, arctan, that's the guy that has 1 over u squared plus a squared, or a squared plus u squared. If I make my a my 3, my u my x, my du is just going to be u prime. That's 1 dx. Check it. This is really going to be 1 over a squared plus u squared du. Oh my goodness, guys, there's a rule for that. Can you tell me what you wrote down? What is that rule? Arctan is the same thing as tangent inverse, right? Dun, 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 boop, boop. Now, back when we were taking derivatives, there wasn't an A. I can look at that another day. There wasn't an A, but there also would have been some rewriting and simplifying that would have needed to happen. This is, A allows us to say this is the simplified derivative. Not the original derivative, but the simplified derivative. But guys, there was no ln. Absolutely none. This is not a 1 over u. This is a 1 over a squared plus u squared arctan. So similarly, can anyone tell me what you think the u would be for number 2? These are straightforward arctangent examples. Arc-trig examples. So what arc do you think?
1.
Which arc are we aiming for, though? What do you think?
Secant.
Not secant. Look, secant has something in front.
Oh.
So let's go for arc sine. And if it's arc sine, then where would your u be? It'd be coming out of, do you see it?
2.
It'd be coming out of this, but why is Victor telling me 2x? The rule says 1 minus u squared. So what's the square root of 4x squared? 2x. What's du? U prime. What would my a be? 1, because it's just a 1 squared is 1. Can I pull this 2 out in front? And the answer is definitely yes. I can pull the 2 out in front. I have 1 over the square root of a squared, because it's just 1 squared, that works, minus u squared, because it's 2x times 2x, times, okay, all right, I could divide by a 2 if I want. So I would have du over 2. But du over 2, what's going to happen when I bring that little 1/2 out in front? From my u prime, move my 2, and then I'm going to move that little 1/2 out in front. And I'm going to land at, well, hold on, 2 over 2. Oh, yeah, the 2 is just the u prime. And I end in, guys, what is the answer to? 1 over the square root of a squared minus u squared. Ah, do you notice it's not a 1 over a? Looks a little different. Arc sine, otherwise known as sine inverse of u over a, which is 2x over 1, which is just 2x plus. I said we just had to do 3, so one last one. Can you make a guess as to what you think the last one's going to be? Yeah, it is. But look at your integral. Do you see that there's something a little bit extra? We have that 3x out in front. For sake of rewriting, I'm going to go ahead and pull that 4 out in front. it's just a constant, it's just a coefficient, I should say. So what do you think your u is going to be? Look at your rule. Look at your rule and form your perspective. 3x. What's your a going to be? 2. Right? A squared. So square root of 4. Okay. You have enough information. Du is just the u prime. So u prime is just 3, right? Mm-hmm. You can make your substitution. Well, hold on. Let's move the 3. And make my substitution. The 4 is chilling in front. What if? I have 1 over u square root of u squared minus a squared times du over 3. That over 3 is a coefficient. Technically a 1/3. Pull that out. And I'll land at, how's my rule work? There's a 4/3 in front, and then what? Times 1 over a arcsecant of u over a plus c, and I think there is one little typo. Does it? Oh, yes. Haha, absolute value. Absolute value of u over 2. You might be wondering, oh no, on Friday we're going to have all the others, right? The arc cosine, and the arc cotangent, and the arc cosecant. But do you guys remember their derivative rules were very, very similar? What was the only difference in the rules? One was a positive and one was a negative? Guess what? If we see one, we're just going to go, if it's a negative, 1 over 9 plus x squared, we're just going to say negative tangent inverse, and we're going to say, forget it, we're done. We're not going to go to the cotangent inverse. We're not going to go to cosine inverse. We're not going to go to cosecant inverse, and neither will the AP. We made it. 3, 2, 1. Take a deep breath, and awesome job.
How did you time that?
I did. Great. Oh, bye, Mo. You missed it. You're on the right side of us. Arcsine, arcsecant.
Right now. What am I looking at? Oh, good word. I can't. Somebody left a word. Who? Oh!
You should learn how to get it.
No, she looks at mine, she thanks me for my word. She's like,
What did you say about my mom?
we'll ask her.
Don't talk about my mom. I love my mom. This is in your chair.
Way too much.
This is in your chair. Yeah. Ow.
Because I was just tripping because I was like,
No. She doesn't even know. She doesn't even know. I was trying to say the last name. I'm not really.
oh, you mean me just basically?
What's your
Yeah. Too bad it's my job. Nutrition, guys. Remember, come back to nutrition. If there's spares, they're yours.
Yeah, Lucius, what do you mean? Well, I'm thinking of the black guy.
No.
That's his name.
The guy was like,